In this video, we are going to talk about solving systems by substitution, and we're going to start with when is it best to use the substitution method. So if a variable is isolated, that's when you want to use substitution. So for a variable to be isolated, that means that it is by itself on one side of the equation. So first, we want to define our variables. So 2 times Antonio's age plus 3 times Sarah's age is equal to 34. Sarah's age is also 5 times Antonio's age. How old is Sarah? So we want to know what Sarah's age is, but we can't necessarily find that out unless we know how old Antonio is. So we have two variables. We'll let them be x and y. We'll say x is Antonio's age. And we'll let y be Sarah's age. That was step 1. Okay, step 2 is going to be writing our two equations. Two times Antonio's age plus 3 times Sarah's age equals 34. That's one equation right there. So 2 times Antonio's age, which we said was x, plus 3 times Sarah's age, which we said was y, is equal to 34. That's one equation. But we also know Sarah's age is 5 times Antonio's age. So now we have two equations. At this point, we want to make sure that we have a variable that is isolated. In the second equation, y is already by itself. So since y is isolated, we can use substitution. As we work this out, there's kind of a two-step process now that we're actually going to start the work. So step 3 is going to be the substitution part, the main substitution piece. Okay, so in this step, since we already know that y is equal to 5x, that means we can take y wherever we see a y and we can replace it or substitute it with a 5x. So in this first equation, where we have 2x plus 3y equals 34, well, we know that y is equal to 5x. That's what the second equation tells us. So we can swap them or replace them or substitute them by taking 5x and putting it in the place of the y. So that would give us 2x plus 3 times 5x equals 34. So all we did right there was, since y is equal to 5x, in that first equation, we took y and replaced it with 5x. So that was our substitution piece. Now we can actually solve for x. And we do that by simply solving out this equation that we have now. So 2x plus, so 3 times 5x is 15x, equals 34. Now we can combine like terms. 2x plus 15x is 17x. And then we'll want to isolate this x by dividing by 17 on both sides. Okay, so that gives us x equals 2. Well, now that we know x is 2, we can take 2 and plug it back into one of the first equations. So we can plug x equals 2 into one of the original equations. Okay, so if x is equal to 2, here's what we're going to do. We're going to take x equals 2. Now, if I want to know what y is, our question is asking how old is Sarah? So in other words, we're trying to find out what is y. So if I want to know what y is, then I can take x equals 2 and I can plug it into this equation since y is already by itself here. So if x is 2, then we can take that and plug it in to this equation. You could plug it into the first equation. You'll get the same answer either way. It doesn't matter which equation you plug it into, but I'm picking the second one because I want to know what y is, and y is already by itself right here. So we're going to plug in 2 for x. So that gives us y equals 10. Okay, so I wanted to know what is y. Y is equal to 10, so that tells us that Sarah's age is 10, or Sarah is 10 years old. Now, there's another way that we can write the solution of a system. We've already looked at this when we looked at graphing, but the solution overall to the system would be the point xy, which was 2, 10. All right, let's look at a word problem. Last season, 2 running backs, a first string and a second string, on the Steelers football team rushed for a combined total of 1,550 yards. The first string running back rushed 4 times as many yards as the other. How many yards were rushed by each player? So we want to know the x and the y value for this. It's asking us for both. So first we got to write our equations. All right. So we have 2 running backs, the first string and the second string. All right, so let's write our 2 equations. All right, so they rushed a total of 1,550 yards. Okay, so x plus y, they're combined, is equal to 1,550. The first string, x, rushed 4 times as many as the other. So the first string's yards was equal to 4 times as many as the second string's yards. So how many were rushed by each player? So here are our 2 equations. This is our system. Now we've got to make sure before we can do substitution, we need to have a variable that's isolated. So we have x equals. Since x is isolated, we can use substitution. Now to use substitution, we're going to say if x is the same as 4y, then I can look at that first equation and plug in 4y wherever I see an x. So if x is the same as 4y, I'm just going to plug that right in for there. All right, so 4y plus y, that's a total of 5y, is 1,550. Now I'm going to pull up Desmos to divide this. So we got to divide by 5. It's 310. So So y is 310. All right, well now, if I know y is 310, I want to know x. So I can take 310 and plug it in for y in either one of the first two equations. All right, I'm going to plug it into the second one because it says x equals, and now I want to know x. So if x is 4 times y, and now I know that y is equal to 310, then I can solve this. So let's see, that would be 1240, I believe. Let's see. Yep, 1240. Number 6, Company 1 earned 0.546 million more than Company 2. The companies earned a total of $9.454 million. How much did Company 2 earn? All right, so let's start by writing our two equations. Company 1, we'll let that be x. Company 2, we'll let that be y. All right, so Company 1, which is x, earned $0.546 million more than Company 2. So Company 2 plus 0.546. All right, the companies earned a total, so together, Company 1 plus Company 2 earned a total of $9.454 million. How much did Company 2 earn? So we want to know what is y. All right, well, before we can use substitution, we've got to check. Do we have a variable that's isolated? The answer to that would be a yes, because we have x equals all by itself. And since we know that x is equal to y plus 0.546, then I can look at this second equation and say, well, if x is the same thing as y plus 0.546, then I can plug that in for x. So x is equal to this stuff. So I'm going to finish writing that equation. And now we need to solve for y. So we have two y's here, so 2y plus 0.546 equals 9.454. Okay, we need to subtract is 8.908. Okay, so we have 2y equals 8.908. And now we divide by 2. So y equals 8.908 divided by 2, which is 4.454. All right, so we wanted to know how much did Company 2 earn. That was our y value. So since we have found our y value, we are done. Michael is 12 years older than Lynn. The sum of Lynn's and Michael's ages is 84. How old is Michael? Well, first we need to define our variables. For our two equations, we know that Michael is 12 years older than Lynn. So if Michael's age is X, is 12 years older than or 12 years more than Lynn's age. So Lynn's age plus 12. Next, we know the sum, or the addition, of Lynn's and Michael's ages. So x plus y is 84. And we want to know how old is Michael. So we're trying to find x. Right, well, I need to check if I want to use substitution for this. I need to make sure that I have a variable is isolated. Since I have x equals, we can go ahead and use substitution. So now I know x is the same thing as y plus 12. So in the other equation, I can plug in y plus 12 for x. Okay, so I'm going to put that in parentheses, y plus 12, and finish that equation. All right, now I can solve for y. So I have 1y plus 1y, that's 2y, plus 12 equals 84. So y is 36. So we found that Lynn's age is 36. Well, if Lynn is 36, then we can find out how old Michael is by plugging in 36 for y. All right, so if I want to know x, or I want to know Michael's age, which is x, is Lynn's age plus 12. Well, now I know that Lynn's age is 36. So solving for x, I'm going to add 36 plus 12 is 48. Number 8, the number of students at a swimming summer camp is 200 more than 3 times that of the hiking summer camp. All right, let's continue reading. The total number of people enrolled at both camps is 1,980. How many students are enrolled at swimming summer camp? So our question is asking us to find x. That's what we want to know. All right, let's write our two equations. So the first sentence, the number of students at swimming summer camp is, so let's stop right there. The number of students at swimming summer camp, we called that x, is, and then we'll finish the rest of it, okay? So the number of students at swimming summer camp is 200 more than, so something plus 200, 3 times that of hiking summer camp. Okay, so it's 3 times the number at hiking camp, and then 200 more than that. So I'm going to make this look a little bit neater. So it's 3 times y plus 200. All right, now let's look at the second sentence. The total number of people enrolled at both camps is 1980. So the total combined, so x plus y, is 1,980. Well, if we want to use substitution, we can, because we have x equals. That variable is isolated. So anywhere we see an x, we can put 3y plus 200 in its place. All right, so I'm going to put my parentheses, plug in 3y plus 200. That's my substitution part, and finish writing out that second equation. So this is the number of students at hiking camp. So the number of students at hiking camp is 445. But we wanted to know X. We wanted to know the number of students at swimming camp. So if we want to know X, we have an equation that says X equals. So the number of students at swimming camp is 3 times Y plus 200. Now that we know Y, we can plug that in. Okay, so let's see. 3 times 445 is 1335. Plus 200. So the number of students at swimming camp is 1,535 students.